Really?
Oh wait, this is a test?
Yes.
Yep, it's over all the transformation
Why
stuff
would
we've
you
been
have a
doing.
test before final?
That is a good question.
We have a quiz over all our stuff to cap it off, and then
We
final
should've
is
done
all together.
A week ago.
I feel like we should have done it on like Tuesday.
What happened?
Would you guys have rather reviewed on a Monday and taken the quiz on a Tuesday?
Kind
What happened to the thing back here?
I don't know what you're doing. Oh, I have it over here. Do you need it?
Yeah, almost.
So now we got.
Stop running.
Oh.
Thanks.
Now I know why you don't read.
That's not even the reason.
Go around the other side and unplug it.
Okay.
I got it.
I just need to know that
Thank you, Debbie.
it's not there.
Yeah.
It was right there.
Alright.
Thank you, sweetie.
Thank you, Dad. Can I have one?
Alright, so it says, can you, oh yes, of course. No, it's okay. My mistake. I give review guys desks. I didn't give it to your desk. Alright.
That's okay.
Which ones are parallel? And define the magnitude. So one of the benefits of taking this before the final is you guys knock these quizzes out of the park, which means now you get to do it again.
Well,
Which should be easy.
What if we have to take a retake? Then what
Yeah.
are we supposed to do?
I know, you're up against the wire here. That happens. I can't make everything perfect. I can try to make it perfect, but I can't make everything perfect.
You got a lot of papers to read.
Yes, I do.
You found your quiz.
I ain't mad. I know I got an A+.
Which means a ton of work for me towards the end of the year. A ton of extra work.
You're not.
I won't tell you to be thankful, but I think you'd rather have the retakes than not. For this, if you need to do a retake, you have up until the grades are due at the end of the beginning of January. So if you really need a retake, you want to come in, call me, we're going to break, we'll get them done. Or, I'll have the grades for you on Monday, you don't like it, Tuesday, Wednesday, Thursday, Friday.
It's like a new update on that.
Right? Best I can do. I figured it'd be better to give you another chance at free points, right? Another shot, because you did so well last time.
Ain't no way.
Okay, here we go. Finding whether which ones are parallel. So what we have to do is find their slope. So we take their components. So like for vector v, it's 4 over negative 2, rise over run. 4 divided by negative 2, well that's just going to be negative 2. U is 4 over 3, which doesn't get any simpler, right? 4/3. A is negative 3 over 3, which simplifies to negative 1. It's negative 3 divided by 3 is negative 1. B is 4 over negative 1, so negative 4. C is 4 over 2, so 2. And D is 3 over negative 3, right? The y part over the x part, the rise over the run. Remember, these aren't coordinates, they're vectors. So we get negative 1. Things that are parallel have the same slope. Well, here's our slopes. Which ones have the same slope? Which vectors? A does. And D does. So I write vector A and vector D doing that little harpoon looking thing, right? That's the symbol for vector. Are parallel. That's the symbol for parallel. That's the only two that are parallel. On your test tomorrow, I'll probably give you 2 vectors and I'll say, are they parallel or are they not? So you won't have to do all of those, just do 2 of them, right? And you'll do that, you'll say yes or no.
Wait, dumb question. Oh, never mind. I got it now.
Next part it says, find the magnitude. Magnitude is the length of the vector, right? So how long are they?
Is that is where?
It is, right? Because the vector can be made into a right triangle, right? I'm not making you graph them this time. But
We
just
do them
right.
for all?
How long? Huh?
We gotta do it for all.
You got a what?
Do them for all those?
Do what for all these?
Find the magnitude.
Yes, but is this? Do you turn this in? No. And I said I give you like 2 tomorrow.
So let's
Right.
do 2.
So you might have to do 2 of them, which is good because they're super easy. You wish I was giving you 100 of them, right?
Yeah, okay. I'm just
What
Yes.
is Spaz?
I just can't help. You know what I mean? I can't win. You want less problems, but you also want more easy ones. we're gonna find the magnitude here. We're gonna do the Pythagorean theorem. So we're gonna take those two numbers, we're gonna square them, add them, and root them. That's all. So -2 squared. Yes, I can. I'm sorry. Oh, me personally?
No, with the paper.
Oh, better.
Yeah, I can see the right.
And then we're gonna add 4 squared to it and root it, right? A squared plus B squared equals C squared, but I want regular C, so I have to root it. Squaring it means multiply it by itself. So we have -2 times -2. Two negatives make a positive, right? What's 2 times 2? 4. 4. So positive 4. 4 squared just means 4 times itself. So 4 times 4, which is 16. Now we haven't rooted it yet. 4 and 16 added together is 20. Does the root of 20 simplify? No. Root 25 is 5, right? Root 16 is 4, so we know 4 and we know 5. That means root 20 must be somewhere in between, right? So just leave it as this.
If you can simplify, do you want to?
I would prefer you to. Will I take off? No. Mm. If I had taught you algebra, maybe. But I don't know what you got last year, right? So, how do you feel about finding the magnitude?
It's easy.
Square them, add them, root them, right? Feedback.
Wait, where'd you get the 4 and the 2 from for this?
I was doing these magnitude, so -2 and 4,
Oh, alright.
right? The components. That says 2 to the left and 4 up, right? So the triangle's going to be 2 to the left and 4 up for the legs.
Do we only have to do one, or does it go for all of them?
All of them. How many?
If you did for a different one, it'd be the same?
If I do it for this one, I'll get 3 squared plus 4 squared rooted, which is 9 plus 16, which is 25, which is 5. That one's longer.
We only have to do it for one.
Yeah, do it for all.
Do it for all of them?
Are you turning this in? No, it's a review guide.
Yeah, I know, but like on the test.
How many of these will I give you on the test?
2. Or 3.
So you'll do it for all of them. Yes.
He gives 1, 2, 3, 4.
Doc, how many am I going to give you on the quiz?
2.
2, thank you.
Maybe.
I'm only giving you crap, and Ede shouldn't be giving you crap because I answered that ahead of time, and then Ede's asked the question, and I told him again, so you missed it twice.
I was writing something down.
It's all good. I'm not mad,
You were listening
but I will give you crap.
It's turned down
I feel like that's fair.
lower than halfway.
White guy stuff here.
I'm so mad.
Not here. Shut
So
up.
mad. Guys, I woke up at 2 a.m. last night to get stuff done because I didn't get enough done yesterday. I went to bed at 8 because I couldn't stay awake any longer.
Down and you're right.
I had to drive home last night with no heat. My windows were frosted, so I had to roll the window down and look out the side to get home.
That woke you up.
That was awful. Yep. And then I got my little heater that came in the mail, right? Just in time. Put it in my car. Thing couldn't warm my hands, right? So it's a waste of $20.
Telling you, a little buddy will do you good.
Now Tucker needs to get me in touch with a mechanic so I can get my car fixed for cheap. All right, so reflecting this point. We're gonna reflect it across that line. This is where the stuff gets a little hairy, so make sure you're paying attention. We're gonna graph that line. It's in slope-intercept form. What's the slope of this line? What's the slope of this line?
1 over 1.
1 over 1, because there's a 1 in front of the x, right? The -2 is our y-intercept, right? So we go down to -2, and that's where it's going to hit the y-axis. What's our slope, Tucker?
1 over 1.
Up 1 over 1. We're going to draw our line. This is going to be our mirror that we're going to reflect the point over. Now I'm going to draw that line. On the one hand, this is a lot of work, but a lot of the stuff that we're doing for this problem is not difficult, so it's kind of free points if you know what you're doing. And if you're struggling with it, ask questions now, I can help you. Then we're going to put A on the graph, right? That's a point. It's -2, -7. So that's here. There's A. How do you feel so far? Yeah, it's not gonna end well for you. Come on, man. I'll worry about you. Alright. So far so good? So now we need to find the perpendicular line that goes through this point. So when we want perpendicular slope, what do we do to the original slope? What do we do to it?
You flip and then you-
Flip and negate it. So if I flip it, It's going to be a coincidence. It's going to kind of stay the same, right? Because it's 1 over 1 now. If we flip it, it's still 1 over 1. But then we negate it. Negative 1 over 1. So our slope is going to be y equals negative 1 over 1. Negative 1 over 1 is just negative 1, right? So I'm going to write negative x plus b. Is everybody cool with that? There's a 1 in front of that x. Negative 1. Okay? So we go from positive 1, flip and negate to negative 1. You okay with that? If it was 2/3, we would have flipped it to 3/2 and negated it, right? But it was 1 over 1, so we flipped it, stayed 1 over 1, and then negated it. Minus 1 over 1, minus 1. Cool. The b value is this part that sticks out here. We don't know what that is. How we're going to find that is that thing is going to be whatever is required to make it go through this point. Right now, all it's saying is it's perpendicular. I can draw a lot of lines that are perpendicular to this, right? Hit it at 90, right? I want the one that goes through A. So in order to make sure it goes through A, I'm going to plug that point in. Starting to remember this a little bit? We're going to plug in -2 and -7. So I'm plugging in -7 for y, and I'm plugging in -2 for x. Whenever you plug it in, wrap it in parentheses. That way you'll notice that we have a negative from the 2, and we have a negative from the equation, right? Tucker, what's a negative times a negative? Good, so that's going to be a positive 2 after we do it, right? So we have -7 equals 2 plus b. And now we've almost figured out what b has to be, right? If I subtract that 2 to this side, I find out that b has to be -9.
Why'd you get rid of the -2? Or why'd you bring the negative?
So I plugged in -2 here, right? And when I plug it in, there's already a minus sign there.
Oh,
So 2 minus to make a positive. Thank you for asking. Great question. So I know that y is going to be -x minus 9. Right, I just took that -9 and plugged it in. So that's our equation. Flip and negate the slope. Plug it in to find b. Feel. Feel okay? Now we're going to graph that. What's our y-intercept, Tucker? For this guy.
-9.
Yeah, -9. So we're going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's where it's going to hit the y-axis, right? Alex, what's our slope?
-1.
Yeah, -1. So we're going to go down 1 to the right 1. See how our red line is going in the opposite direction of our blue line? Our blue line was up 1 over 1. Our red line's down 1 over 1. So there's our red line. A lot of stuff, but a lot of very doable stuff, I think. We're not done with this problem. Okay, so relax for a bit. First part's not so bad, right? So now we're actually going to reflect that point. The reason we did all this crap is so we could know where A prime is going to end up after we flip it, right? It's going to be somewhere along this line. We know it's going to be the same distance on both sides because it's a reflection, right? So what I'm going to do is I'm going to find out the middle point, which is going to be where these intersect. Now it's a gross point, so buckle up, okay? Let's figure out what that point is. You can't really eyeball it, right? It's kind of in a weird spot. So here's how I'm going to figure out where it is. Where they intersect is where they equal each other. So the question is, where does this equal that? That's what we're asking. It'll be that point right there. So see how y equals x minus 2? Well, if y equals x minus 2, can't I switch it out down here? Can't I substitute x minus 2 here? And have x minus 2 equals -x minus 9? I'm going to put that x minus 2 in for y, because that's what y is. So I'm going to plug x minus 2 in for y, right here. X minus 2 equals -x minus 9. I'm going to find out where they equal each other, where they intersect. I'm going to add my x to this side. That's 2 x's. And I'm going to add the 2 to the other side. -7. Adding the x over makes 2 x's. Adding the 2 makes -7. Still with me? We'll take a break for a second. So now I'm going to divide by 2. Fractions or division for lazy people. What's negative 7 divided by 2? Negative 7 over 2. That's it. It's gross, but you're done, so who cares? What's 9 divided by 2? 9 over 2. What's 12 divided by 7? 12 over 7. That's it. Negative 7 divided by 2 is negative 7 halves. So where they intersect, our midpoint, is going to be negative 7 halves for x. Now we're going to go find what y is. Okay? Here's what we do. We're going to take that. I'm going to plug it back into either equation. Doesn't matter, right? Because it's where they agree. They're both going to have the same answer. So I'm going to plug it back into the easier one. Let's plug it into the top one. So I'm going to take y equals, and I'm plugging in negative 7 halves for x. So negative 7 halves minus 2. So we need common denominators to put those together. We've got negative 7 halves here. We're going to subtract something else with halves in it so they have common denominators, right? So the question is, how many halves are in 2? 4 halves, right? 2 halves in 1, right? 2 over 2 is 1. So 4 halves in 2. And check your work. Is 4 divided by 2? 2? Right? 4 divided by 2, is that 2? Yeah, so we didn't change anything, we just wrote it a different way. It's still the number 2. But now we can see they both agree, right? They're both halves. So I've got negative 7 halves, and I'm subtracting 4 more, so now I have negative 11 halves. Right? Negative 7 minus 4 is negative 11. So negative 11 halves. It's gross, but it's going to be all right. It's going to be all right. This is as worse as it can get. Okay? What we did there, since we got this guy, is we just set them equal and solved for x. Then we went back and solved for y. If the numbers weren't fractions, wouldn't even be a thing, would it? Be pretty easy, right? If the numbers are fractions, you got to get common denominators. That's a little tricky. If you need help with that, raise your hand. Okay? There it is. How you feel? Okay. We got one more thing to do. It's going to look like a lot because I'm showing every single step. We're going to be all right. Here's the idea. Normally, with midpoint formula, we have 2 outside points. We plug them in, and it pops out our middle guy, right? We already know our middle guy. So instead of plugging in the 2 outside points to get in the middle, we're going to plug these 2 in and get one of the outside points. Words are hard. We'll see in a second, okay? What is midpoint formula? Average of the x's, average of the y's. Remember? What do we do when we average stuff? How do you average something?
Add it.
You add them all up, and then what? Divide by the number of pieces, right? How many you're doing, right? So we're going to add them all up and divide by the number of pieces. If I see someone write subtraction for the midpoint formula, it tells me you really don't know what it's about, right? It's averaging. You would add them and divide the number of pieces. So midpoint formula, don't write this down, I'm just showing you what it is, okay? Is we're going to add up our x's, whoops, x1, and we're divide by the number of pieces. How many x's I have there? 2, right? I'm going to add up my y's and average them. How many y's do I have? 2, so I divide by 2. Right? Now, we know what the midpoint is for this, right? We already know what it is. So I'm going to plug that in here. It's negative 7 halves, negative 11 halves. Looks gross, but it's going to go away, don't worry. Over here, I'm going to plug in what I know. Now, normally, right, for midpoint, I know my outside points, and I plug them in here, and then I get the midpoint, right? But I only know one of my outside points, just A. So the other one I don't know. So I'm going to leave x2 and y2 alone. That's the point I don't know. And I'm going to plug in the point I do know. I do know A. I don't know the other one. That's going to be A prime, the reflected one, okay? What's A's coordinates? They gave it to us, right? What's A's coordinates? So I'm going to plug in a negative 2 and plug in a negative 7. You take your 2 outside points, you average them, and you get M, right? Well, I only know one of the outside points, and I already know M. The other guy is the one I'm looking for, the reflected point, right? How do Not great maybe, but okay. This is where things get a little weird. But if you're feeling great, you should be feeling great about yourself. So now, this part, they equal each other, and this part equals each other. We're going to go find what x and y are, and we're going to be done, okay? So this right here is x2. Is there a better way to write x2 plus negative 2? How can I write it? x2 minus 2, right? Plus a negative 2 is just minus 2.
You pull that down.
Yes. And that's going to equal negative 7/2. So this part equals that part. I just set that up. Cleaned it up a little bit. Instead of plus negative 2, it's just minus 2. All right, so we want to get x on its own. We want to find out what x is, right? So I need to get rid of the minus 2 and the divides by 2. We always get rid of division first. Makes a better world, right? Bring people together. So, how do we undo divides by 2? Well, division is divorce. How do you undo divorce? Multiply. Right? So, we're going to multiply by 2 to both sides. When we do that, it gets rid of the divorce, right? And on this side, we have negative 7 divided by 2 already, right? If we have negative 7 divided by 2, and then we multiply by 2, doesn't the divide by 2 and times 2 cancel? So all we get left is negative 7. The fraction goes away. Because they're both divided by 2. When you times them both by 2, it cancels the bottoms, right? That's convenient. Thank you, Mr. Mack. So now we're just going to add 2. We find out x2 is negative 5. So a prime is going to be at negative 5 something. We just got to go get the other one, right? The y. That's here. So I know a negative 11 over 2 should equal y2. That says plus minus 7. Is there a better way to write that? Minus 7, right? How do I get rid of division? Multiply. Because they're both being divided by the same number, that goes away on both sides. And then I add 7. And you can trust me. Negative 7, negative 11 plus 7 is negative 4. There's a prime. Definitely the one on the test that takes the most work. But about half of it isn't too bad. So I'll balance out the other half. If you need help, raise your hand on this one, okay? I can get you through it. You will be okay.
How many
If I
of them we
graph,
gonna have?
what?
How many of them we gonna have?
One.
One.
If you graph this guy, negative 5, negative 4, check it out. Negative 5, negative 4, it's on the red line, like we said it would have to be. And it's the same distance on both sides. So we flipped it correctly. That's the hardest thing we've been doing all semester. But let's break it down. Can you graph those two things pretty easily? That's free. Can you take the slope, flip it, and change its sign? Right? Can you plug that in and find b? I bet you can do that half. Set them equal. If the numbers are nice, you get a number. You plug it back in, get another number. I bet you could do all that without much issue. If the numbers are nice and not fractions, I bet you could do it pretty easily. Midpoint is average of x is average of the y. Just plug in the one you know. Plug in what you got. Get rid of the division, add. Get rid of the division, add. Here's your answer. It's a lot, but it's the hardest one on here. If it's going to be the hardest one, that's not too bad. Could be a lot worse. First half you should feel pretty good about. Turn the page. 3 is the same thing, so we're going to skip it. Just more practice. My numbers are messed up, so there is no number 4. We're going straight to number 6. Sorry, guys. 2 a.m. We're translating. You guys love this stuff. That means sliding it, right? So I'm on A, and I'm moving to A prime, right? Looks like I'm going up and to the right. So I'm going 6 to the right and 4 up. So I'm using this vector, right? 6, 4. 6 to the right, 4 up. It's going to be true for all of them, right? When you push something, you push it by the same amount. So what's our rule going to be? We're going 6 to the right and 4 up. What do I do to my x and my y? Add 6 to the x, add 4 to the y. That's it. Remember when that was hard? I moved 6 to the right and 4 up, so I add 6 and add 4. I don't, I'm sorry, I'm all out. Yes, please. So here's what I would do to fill out the rest of this. I'd write down my points, right? A looks like 2, 0. B looks like 0, 3. Et cetera, right? What I would do next is I'd add 6 and add 4, and I get these guys for free without having to count them. If I add 6, I get 8. If I add 4, I get 4. If I add 6, I get 6. If I add 4, I get 7. Saves on counting, right? Which you're gonna screw up because counting is hard. Let's be honest, right? Counting boxes sucks. Anybody that's ever done inventory can tell you that. I can do math. I hate counting. Same thing for C and C prime. Okay. Let's look at number 7. Same dumb thing. We're sliding, right? So we're gonna use a vector from B to B prime. Looks like we're going up to the right again. So it's going to be 1, 2, 3, 4, 5, 6, 7 to the right. So 7. And 4 up. 7, 4. So what's our rule going to be? Add 7, add 4. You could write down the coordinates, I bet, right? Free points, what coordinates are right there?
It's 5 up.
Is it 5 up, not 4 up? Can't confirm, but you've been doing that wrong all day. 1, 2, 3. Oh, it is 5 up. Oh man, add 5. Catastrophic, minus a half. If I had to do a retake, I wouldn't even make myself do it. You know that, right? If you only miss a problem by a half, I don't make you redo it. Guaranteed a better score every time. Let's look at 8. Now we're reflecting. And it's an easy reflection. Right? We don't have to do that perpendicular stuff that we did before, draw the lines and all that, right? None of that. Are we okay, Debbie? Are you alright? Yeah?
No, I missed that. That's okay. I'll get it from you later.
Yeah, right now.
Kristen had asked me a question about one before. Oh, thank you, sir.
You.
It was just answered in the notes, so I ran next door to give it to her. She was still learning. Thank you, sir.
Just math needs. No problem. So, we don't have to do anything crazy like we did here, right? This is a reflection, right? That's complex. This guy, we're just flipping it over the line. If B is 3 away from the line, after we flip it, it's still going to be 3 away. So there it is. B prime. If A is 6 away from the line, after we flip it, it's still going to be 6 away, right? Now it's mirrored. Could you write those coordinates down? I bet you could. Now guys, when I flipped this over the line, when I reflected it, did I flip it horizontally or vertically? Vertically, right? So which variable gets negated, the x or the y? The y, because y is the vertical variable. So our rule is take the x, negate the y. That's it. If you check your coordinates, that's what works out, right? Looks like A is 2, positive 6. After I'm done, it's 2, negative 6. So A goes from 2, 6 to 2, negative 6. So what did we do? We kept the x and negated y. That's all. I told you this one was the hardest one. 9. It's going to be a little more complex on 9. You ready for it? First off, what direction am I flipping this in? Horizontal or vertical? Horizontal flip. So I'm going to negate the x, right? Now here's the issue, and I'll show it to you in a second. Let's flip it on here using logic. How far apart is A from the line of reflection? Looks like 5, right? So after I flip it, it better be 5. 1, 2, 3, 4, 5. That puts it right here. A's original coordinate was negative 10, positive 6. Trust me on that, okay? That's where A is normally, if you go from the origin, right? A prime's coordinate is 0, 6 now. Now here's the deal. Our rule says, if you negate the first one, you should get the new one, right? But here's the deal. Negative 10, if I negate it, do I get 0? I get positive 10, right? So I need to adjust for this. After I negate it, I get positive 10. Is everybody with me there? I get positive 10 after I negate it. But now I need to slide it to 0. So if I'm on 10, positive 10, what do I need to do to make it go to 0? Subtract 10. I'm on positive 10, right? Because I negated it. And then I subtract 10 to get it to 0, right? So I'm going to do minus x, and I'm subtract 10, right? That's what I'm going to do. That's my rule. Now B is on the right side of the line of reflection. So if I flip it across the line, it's going to end up on the left. It's going to end up right here. Is everybody cool with that? I think that's what's been tripping some people up. B flips across the line this way. A goes that way. C is going to be on the other side of the line as well. When you connect those dots, it's going to mirror your triangle. Now it's just going to point the other direction, right? Don't be weirded out by that. They just flip across the line. C goes to the left, B goes to the left. A is already on the left, so it's going to flip to the right. You with me? How you feel, Doc?
Pretty good.
Excellent. Yeah.
Wasn't making negative 20 then? You did positive 10.
We negate the x first. Negative 10 becomes positive 10. Then we subtract 10. We get 0.
Okay, I'm making something.
That's okay. That's okay. You okay? I know, right? Page 6 is blank. I could not figure out how to delete this page. Microsoft Word was being dumb. Could not figure it out. Kept trying to delete it, ended up deleting stuff here. So, sorry. It's an even number of pages though, so it would have been a blank page on the back anyway. So, at the end of the day, would have been the same amount of trees. I tried, I really did. Dilation, centered at the origin, right? I'm sorry, not dilation, rotation, bless you. It says rotate 180 degrees. We could draw L's, right? Takes a lot of time, gets the job done, but it's kind of messy. But now we know the rules. Check it out. Am I going regular geometry here? I can't believe we talked about this or not. Stop me if we have, okay? If we have, we'll draw our L's. If not, that kind of sucks, but still works. So, imagine I have a coordinate up here, right? It's positive, positive, right? Positive to the right, positive up. Okay? If I want to rotate 180 degrees, look at this L. It's going to rotate 180. That's 90. 90 again, it's going to point this way. You with me? That's 180 degrees. Now that it's down here, it's negative, negative. It's going to left and down. This part right here was originally horizontal. After we do the whole thing, it's still horizontal. So X and Y don't switch spots. Y was vertical. After we do it, it's still vertical. So our rule is going to be take your X and Y, keep them in the same spot. Horizontal stays horizontal, vertical stays vertical. You with me? We went from double positive to double negative. So that's our rule. How do you feel about that? That's the rule for 180 degree turn. Meaning take any coordinate you want, and if you negate them both, you flipped it 180. How do you feel? So, here's what I'm going to do. Instead of drawing L's, which I can do for all these, I know what the rule is going to be. The rule is, I'm going to take my X and my Y, I'm going to negate them both. So I'm going to write down the coordinates here. Let's write down B's coordinates. Looks like it's 6 to the left and 3 up. So after I do my rule, I negate them both. What happens when you negate negative 6? What happens? Turns into positive, right? What happens when I negate positive 3? Turns into negative 3. Check it out. 6, negative 3. 1, 2, 3, 4, 5, 6, down 3. There's B prime. That looks like 180 degrees across. Let's do it for all of them. A is 6 to the left and 6 up. So when I negate them both, what do I get? Positive 6, negative 6. Positive 6, negative 6. There's A prime. Right below it. Better than drawing L's, isn't it? Taught you the L's, that way you know why it works and be able to understand what that is, right? But once you know the secret, use it. Especially if you understand why it works. C is negative 3, positive 3. So after I negate them both, I'm going to get positive 3, negative 3. C prime goes there. 180-degree rotation. Took that triangle and flipped it around. How do you feel about that? Could you have drawn L's? Sure. Do you know why that's the rule?
Just because.
That's not going to cut it. When we do a 180-degree rotation, the horizontal part, after we turn it, stays horizontal. It's just pointing a different direction. Instead of pointing to the right, it's pointing to the left. So it goes from positive to negative. Up goes down. Still vertical, right? So it's still X and Y in that order. But it's going from up to down, so from positive to negative. You okay, Doc?
Can I go to the bathroom?
Yeah, it's not here.
Alright.
90-degree clockwise about R, number 11. What's the rule for a 90-degree clockwise rotation? Well, 90-degree clockwise this way. So our L is going to turn like this. Right? See that? It's going from here to here. To the right, I'm sorry, yeah, to the right and down. This quadrant's plus minus. Do X and Y change spots for this one? Yeah, because what was once horizontal is now vertical. And what once was vertical is now horizontal. So our rule is X and Y change spots. Like that. They change spots because horizontal becomes vertical, vertical is switched to horizontal. And we negate the second one. That's our rule. So instead of drawing our L's and getting lost, A is 3, is it 3? 4, 0. Our rule is flip them and negate the second guy. So I'm going to flip them and negate the second one. 0, negative 4 is here. That's 90 degrees clockwise. Let's do C. C is 6, negative 2. After I do my rule, I flip them and negate the second guy, negative 2, negative 6. C prime goes here. If you did to B, B would end up here. There's your 90-degree clockwise rotation. Oh, I'm sorry, you couldn't see. There it is. How do you feel? Are you okay, Brent? No? Yes? Okay. Ava, how you doing? What's the rule for a 90-degree counterclockwise rotation? I know that's not what it says for number 12, but if I did ask you about that, it's going the other direction. Our L ends up looking like this. Do X and Y change spots? Or do they not? Do they change spots or do they not? They do. See how the horizontal becomes the vertical?
When it's negative Y.
I'll get there in a second. See how the horizontal part becomes the vertical part after we turn it? And how the vertical part becomes the horizontal? That means X and Y switch spots. They trade roles. But now we're over here, so we're going negative positive, right? We're negating this guy this time. Let's look at 13. That's what we just did. Counterclockwise about R, you're drawing your L's. You could do that. There's our L, counterclockwise, going this way. My L's over here now. C prime. We've done rotations with this, right? Where it's not on 0. Just gotta draw your L's from there. Okay? So do that. When it's on 0, 0, you can use those rules. When it's not, you gotta use this. 14. Explain the rule for a 90-degree rotation, 90-degree counterclockwise rotation, and 180-degree rotation. That's this stuff. X and Y switch parts for some, don't for others. Here's the written explanation for all of those. This is from our review guide from earlier in the year. I'm just recycling it. Here's a copy of the explanation. I'm going to only ask you to do one of the rotations and talk about it tomorrow, so I only wrote one of them down. Number 14 is on the page I'm giving you. Talks about what happens when you flip it over the x-axis and the y-axis. All you have to say is, if you're flipping it over the y-axis, it's a horizontal flip, so we negate the x. If you flip it over the x-axis, it's a vertical flip, so you negate the y. There you go. Almost done. 17 says dilate it by this rule. From 0, 0. So we're going to negate the x and triple the y. Plug in your coordinates, do the rule to it. Can you do that? C is at 1, 3. If I do the rule, it's negative 1, 9. Negate it, triple it. Plot your points. Look at number 20. We gotta find the rule. Here's how you find the rule. Eve's not right now, I gotta have them paying attention. Look at A and B. We're starting from there and going here. We're shrinking, right? How far apart is A from the origin horizontal? Looks like 1, 2, 3, 4, 5, 6, 7, 8. After I'm done, it's only 4 apart from here. So that's our x value. We went from 8 to 4. What did we do to the x? We divided by 2. Cut it in half. We halved it, right? Half x. A is 6 vertically. After we're done, it's only 3. So what do we do to the y value? We halved it again. And then you write down those coordinates for 3. Look at 21. C is 3 away, and now it's 3 to the left. So we've got 3 to the right, now we're 3 to the left. What do we do to the x? Negated it, right? 3 to the right is positive 3, 3 to the left is negative 3. C is 1 vertically away from the origin. How far is it away after we're done? 2, right? So we went from 1 to 2. What do we do to that? Doubled it, right? We went from 1 to 2. So there's our rule. That's it.
Go back. Ready? See, I like what right between speaker and your tape.
There. Would you like to talk more about these last few ones? Or are you good? You could be good, right? In theory, that might have been enough to get the job done. But if it wasn't, ask questions. That's why we have the end of class. Let's talk about this. For a 90-degree clockwise rotation, the blue goes from horizontal to vertical. And the red goes from vertical to horizontal, so x and y switch. That's what I wrote. We go from double positive to positive negative, so we negate the second guy. How do you feel, Ivy? Okay about it? For a 180 degree, see how it stays horizontal and it stays vertical? So keep the x and y the same. We negate both. That's the explanation. This one, horizontal flip. Negate the x.